we are given that we have $20,000 loan, so obviously he wants his $20,000 back. At the end of the year, he also wants 6% more of the $20,000. If I factor the $20,000, it comes out $20,000 onto what he borrowed plus what additional he wants for the privilege of my borrowing that money, which is $20,000 times 1 plus 0.06 raised to the 1 power, which turns out to be $21,200. Or, in economics shorthand, he'd tell us that the future value is equal to the present value of the money originally loaned times, and then I'm trying to figure out how to get F out of P. The way to do it would be to multiply it times F over P, in which case it looks like the P cancels the P, leaving me with F, which is what I'm looking for in the first place, is equal to P times some factor from a table. And the indicator here nicely tells me exactly what table to go to, exactly what column to go to, and exactly what row to go to. To find the future value, I multiply the present value of the money borrowed times F over P says use the F over P column. I says go to the I% rate table. There's a 4% table, a 6% table, so on. And go to the row that has the number of years or periods across the table. If you do that in your handbook, you'll find, again, we just looked it up, the number is 1.06, you get the same answer. Now, just for your reference, if I forget to give you the interest rate on any of these problems, you can count it's probably with 6%. I tried to stick with 6% on all of the problems, simply so that I knew we had a table that had those numbers in it. Now then, let's say we borrow the money for 2 years. Well, then the guy wants his $20,000 back. He wants 6% of $20,000 at the end of the first year. That's called the compounding period, is 1 year. And at the end of 1 year, in effect, I really owe him $20,000 plus 0.06 times $20,000. If I would like to borrow it for another year, then I will owe him some more money on top of what I already owe him. I'll owe him 6% of $20,000 because I borrowed $20,000 for another year. And then I'll also owe him 6% of the interest that I owed him at the end of the first year, which comes out 20,000 times 1.06 squared, which is a new number, and so at the end of 2 years I'd owe him $22,472. In economics shorthand, the future value of a stream of money can be found by multiplying the present value of that stream of money times F over P times I times N, or at least times the factor that contains those variables. As before, you know which column to look under, because if you want to change P into F, you got to multiply it times F over P. The P's appear to cancel, leaving F. In that case, if you look up the F over P column at 6% for, then you look on the N equals 2 row, you get $20,000. You can check this number in your reference manual. It's 1.1236. It turns out you owe him $22,472 at the end of 2 years. Now these numbers are not exact. A lot of times when you check things and work with things, you'll find out the numbers don't turn out exactly. You're $1 or $2 off out of 100,000, but that's plenty close for our purposes, and to demonstrate that you know how to work these problems to the Board of Registration. All right. Now, in general, all of the tables work this way. In general, these don't have any meaning at all here. There isn't any Q, there isn't any M. But I'm just saying that if any person comes around and says, I would like to tell you the number M, and I'd like to find out what Q is. If we have some rules to do that with at some percent rate for some number of years. Well, you could care less what these things say. For instance, if it gives you M and you want to find Q, then you multiply it times Q over M. That tells you which column in the tables to use. The M appears to cancel the M, leaving Q, and that's what you want Q. The factor will also be a function of the percent rate utilized in the problem and the number of years or months or periods that you borrowed the money. Now then, you may or may not know what annuity is. You may or may not know what a gradient is. I'll show you what each of those are shortly. But I just wanted to emphasize the fact that even though you may not know what an annuity or an annual amount is, if you are given the annual amount you want, and you want to know how much present money to stick in the bank so you can have that annuity as you get old, there's no doubt about what to do. You multiply times P over A because the A's appear to cancel, thereby leaving P, what you're looking for, at some interest rate for some number of payment periods or maybe some number of years. If you wanted to perhaps change future value back into an annuity or an annual amount, this might ask you, how many dollars would you have to put in the bank each year in order to be able to take a lump sum of money out in the F future? Then you would do the same operation. To get A given F, you use the A over F column. It appears that the F's cancel, leaving you A. This factor will also have to be checked to get the proper interest rate and the proper number of years. Now, the manual may put the wording in a little bit different way than you're used to seeing. So you got to be careful if you're saying, are you going to get something from something? Or are you going to transfer a given something into something else? Or if you want this and you got this, be very careful that you're not working the problem backwards. If he says you want to get the gradient from an annual amount, in other words, from an annual amount means I'm given the annual amount, so the given goes on the right-hand side of the equation. And to get G from that, I multiply times the G over A factor. To get the present value of a future value, see here the future value is given. So you put the future value on the right-hand side. You want to get its present value. Then you would multiply it times the factor P over F, where F appears to cancel F, leaving you with P. Now, sometimes the reference manual doesn't give you a column for something you may need. In other words, he may say, I'm going to give you the annual amount, and I would like you to find the gradient. Now, even if you don't know what an annual amount is, and if you don't know what a gradient is, you don't care, you should know what to do. What you do is you multiply what you're given, the annual amount, times some factor, G over A, where the A's appear to cancel, leaving you with G, which is what he asked for, even though we don't know what it is. But when you look in your reference manual, you will find that G over A is not listed. Well, it's even slicker the way we're doing business here, because if you would like to get G over A, but he gives you A over G and does not give you G over A, all you have to do is divide rather than multiply, because G over A will be 1 over A over G. So if he doesn't give you G over A, simply divide by what he does give you, A over G. Thereby again having the A look like it cancels with the A, and G being in the denominator of the denominator goes to the numerator and leaves you G. Also, sometimes you may find that Something else is not given in the reference manual, perhaps F over G, and G over F also may not be given. In this case, someone has asked you to take a gradient and change it into a future value. If you are not given F over G and you're not given G over F also, dig around a little bit and see if you can't put one together. For example, you do have a factor F over A, and you also have a factor A over G. Well, in this case, these two factors, you'll notice that F over A, the A will cancel the A in A over G. This A cancels this A, leaving you with F divided by G, which is the factor that you're looking for. Now then, going back to our previous discussion of borrowing the money from the bank, $20,000. What if we want to borrow it for 7 years? You have two choices. You can multiply